Can someone quickly summarize what have we discussed in our last session?
So we discussed about context switching and synchronization. Context switching. It is like switching of the CPU from one process to another processes.
Process or thread?
Yeah. So it is like a feature of a multitasking operating system, and it allows a single CPU to be shared by several processes. And we talked about synchronization. Basically, synchronization put the lock on a particular thread. When two or more threads access the same resources, they need some way to ensure that resources. They need some way to ensure that resources to be used by one thread. So synchronization help that thread to secure the resources for that particular period of time.
Right. Yeah. Yeah, that's right. So thank you, Varsha. So yeah, so basically synchronization technique will help us to put a lock on the shared resource, whatever our program is trying to, or threads are making use of, right? So that you get to use only one thread can access that shared resource. Okay, let's take one example. Suppose you are doing a countdown, like you're doing a countdown from 100 to 1, for example 199, 98 and all, right? So when you do a countdown, you would normally see a one by one value decreasing and eventually reaching to 1, right? In case of multi-threading, if multiple threads are trying to decrement this value, and if we don't have a proper synchronization technique in place, you can see suddenly the value dropping by 3 or 4 points at a time suddenly, right? Like you will see 100 and then 97. Suddenly three points will reduce because multiple threads may be accessing that value. If there is a proper synchronization in place, every thread will decrement only after previous thread has decremented its value, right? And at the same time, there will be read issues also. If there is no synchronization and multiple threads are working on a certain shared variable, let's assume certain count, for example, and initially the value is 10, right? And like now both threads, one thread want to increment that count to 11, and another thread want to decrement that value to 1, for example. Sorry, decrement that value by 1, and other thread want to increase that value by 1. This is the functionality we have, right? So if the first thread comes and it tries to decrement the value of the thread by 1, and at the same time, if there is no lock on that particular counter, right, other thread will go and increment. So both threads are seeing the value as 10, other thread will make it as 9, other thread will make it as 11. But what will be the final value here? I'm just giving you guys a scenario, okay? There is a shared variable like this counter, okay? And its value is 10, for example, okay? You have two threads now. Thread T1, it is trying to add +1, and the thread T2 is trying to do -1. What will be the final output? When both thread, and there is no synchronization implemented here, okay? So there is no lock on counter. What will be the final value here? That's a give take us.
So right? T2 being 10.
T2 value will be 10.
Okay.
Sorry, no, I didn't understand. Come again.
So is T2 is 10? You're referring T2 as a 10?
T2 as?
the value of T2 is it 10?
Yes, see, both threads are trying to modify this counter variable.
Okay.
Thread T1 is trying to do +1 of this counter variable. Thread T2 is trying to do -1 of this counter variable. Okay. Now, when both threads, if there is no synchronization, both threads will try to read the value at same time, right?
Yeah.
So, but after both threads execution got finished, what will be the counter value?
I think it will be 10. Yeah.
It will be
10.
10. Okay. Any other answers? There is no guarantee. Okay. It can be 11, 10, 9.
Okay.
You're understanding, right? It depends on which thread enters first and which thread enters last. Like both T1 and thread 2 might be reading these values. T1 has incremented the value first. For example, it made 11. And then T2 initially it read 10, right? Now it will try to put 9 because T1 finished first and T2 thread is executing last. End of the day, these threads will also update that counter variable to respective value. No? So based on which thread finishing last also, that output will change. So there is no deterministic output here, if you see, right? Because threads accessing that shared variable at same time, isn't it? So that's why when you put synchronization in place, the moment T1 thread tries to read the counter value, T2 cannot read it. Okay, so T1 comes, it increments it by 11 and T1 finishes its execution. Then T2 comes. When T2 comes, T1 basically gets lock first, increments that value from 10 to 11, and then T1 releases the lock. And because it finished its execution, now T2 will come, it gets the lock on counter variable, it will see the value as 11, and again it will try to decrement it as decrement by 10, and then it releases the lock. So that's how synchronization helps us to ensure the results are accurate, so that whatever, when multiple threads are accessing some shared resource, right? It keeps the system consistent. Okay. And in addition to this, we also talked about this one, right? Which is the deadlock. What is deadlock?
When the thread is blocked, it doesn't come back to runnable state.
Right, but what exactly is deadlock?
When thread is in dead state.
There is no dead state, okay? But what is a deadlock?
When thread terminates or...
Okay. So it's like, suppose you have two objects, object A, okay, and object B, okay, C, okay. You have two objects like this. Now, thread T1, okay, thread T1, it has lock on object A, okay. And similarly, thread T2, it has lock on object C, okay. Understood? This is the scenario, initial scenario, okay. You have two different objects, object A and object C. Thread T1 has a lock on object A and thread T2 has a lock on object C, okay. Understood so far? Guys, understood this?
Yeah.
Now, thread T1 wants object C to perform its operation. In addition to object A, thread T1 also want object C. Will it get object C? Will
No.
thread T1 get object C? Why? Because thread 2 has lock on it.
Yeah.
When thread thread 1 asks for object C, thread 2 says, I need this object, let me finish my execution, then I'll give you this object. So thread 1 will, okay, fine, then I'll wait. Thread T1 will be in a waiting state. Okay, waiting. Okay, or blocked. It will eventually go to blocked after some time. Now thread T2, what it will do? It also needs object A to finish its execution. So it will request for object A. Will it get? T2 will it get object A? Will thread
No,
T2 get object A? It won't get because why?
because T1 has lock on A.
T1 has lock on A. Why? So if you see here, T1 is holding lock on A and requesting for C, which is locked by thread T2. And similarly, thread T2 has lock on C and it is requesting for A, which is locked by T1. Here, none of the thread will get whatever they want. They will keep on waiting in this situation indefinitely. They will be in blocked state forever. And this is called a deadlock. Okay. I mean, they just normally ask, right, what is a deadlock in interviews? At least if you are able to tell this, then it's good. Okay, 𝐷𝘰𝐿𝐴, deadlock. This is a deadlock scenario when basically two threads are waiting on object which is locked by another thread, and other thread is also waiting on the object which was locked by the other thread which is requesting for its own object. Then it's a deadlock scenario. Okay, like none of the thread will get the here thread 1 will never get object C, thread 2 will also never get object A. Both are waiting for objects which are locked by each other. Okay, understood, right? So in this type of scenario, what is the solution, right? Normally, if similar conflict happens, in general humans, right, what we do, we just tell them to, like, one of you compromise or something sort of we do, right? Here what will happen is immediately we try to restart a system. Okay, a restart system, so that threads will release both the objects. And sometimes this can be timing scenarios also. Okay, like if thread 2 kind of execution kind of it kind of delayed for 5 seconds, thread T1 might have got object C, it might have finished its execution and then would have released both object A and object C. And thread 2 then comes in, gets lock on object C, and then again gets lock on object A, and it can also finish it. If there is a slight time delay, rather than both threads competing for two different objects at same time, if one thread can compete at little later point, then it's fine. Yes or no, right? So that's one aspect. Like when you restart servers, the timing scenario comes into picture, and this will get resolved automatically. But eventually, we would take thread dumps and we would analyze what is the underlying issue a bit more, and from the code perspective, we analyze and we try to fix this. Okay. So I think that's all. I think with this we covered multi-threading concepts. So I want to move to the last concept in Java, which we are going to discuss today. And I think today's session basically marks the end of our Java. Okay, end of the Java course. I mean, and in our next class we'll be moving to Spring and other frameworks. So today is the last session for Java. Okay, so today I want to basically cover the collection framework, which is the most important framework in Java. Okay, I mean, you have this java.util.package in Java, right? Like java.util, one particular package was there, and just give me, yeah, java.util.package is there. Okay, so in that we have a lot of utility methods provided by Java. Like I'll just quickly show you. Import java.util. Okay, if you see util, inside this util package, Java predefined package. This is a predefined libraries. In this, there are hundreds of libraries that are that will be helpful to us. Okay, if you see here, with util start self concurrent atomic function, jar logging, pref regex, SPS stream. There are a lot of packages like this. Zip. Okay, zip is to compress, and then within util, if you see, there are a lot of classes like this. Comparator linked hash map, if you see here, right? A lot of interfaces and a lot of collections. Okay. So Java util is basically a very important package. Okay. It also has functions related to team internationalization, right? Like you're working for certain say some website, right? And it is displayed all across the country, all across the web. And if you want to display time in that website, depending on the country they open, the user access that website, right? By, like, say someone accessing from US, someone accessing from UK, or someone accessing from Australia, right, across the globe, or someone accessing from Japan. Like, if they want to if the user has to see their own specific, all with respect to data and time management in our applications also, that particular APIs, everything is included in this util package. Okay, it has a lot of libraries, and we will specifically focus on the collections utilities, basically, right, in this part. And this is a pretty important whatever we are going to discuss today. Okay, and on day-to-day basis you would be working on these collections quite a lot. Okay, so the key idea for building collections is nothing but I hope you guys, at least I think we have a couple of beta students in this class, right? So you might have come across this data structure subject in your graduation, isn't it? Anyone from computers background, computer IT information technology background, right? So this particular framework, collections framework, it's developed on top of the data structures concepts. Okay, in data structures we have things like arrays, hash tables, maps, sort of many concepts, right? So on top of that, this collection interface was built. I mean, those were logical concepts, and collections were uh, a concrete implementations of those logical concepts. Okay, so this is basically the most powerful framework of Java, collections framework. Okay, and it basically contains so many hierarchy of interfaces and classes, which basically provide a lot of ways to manage a group of objects. Okay, so let's just look at the definition for a very high level, and then we'll just dig into what it is exactly and how it will basically help, right? So see, I'll just read out the definition, right? A collection is an object that represents a group of objects. A collection framework, collection is an object that represents a group of objects, right? So normally, if you take, for example, let's take one class, okay, something like this. Okay. I'm just creating one package here. Okay. Over here. Somewhere I'll just. So you have a class like this, okay, a simple employee class. Let me just remove all this or comment all this for now. I'll remove. Okay. You have an employee class like this, simple class, right? and the employee class has certain attributes like this: employee name, employee ID, experience of the employee, salary of the employee, and age of employee. This is uh, the state of an object called employee, right? And normally, if you take an organization, or any organization for that matter, you would have a multiple employees, right? A group of employees. And in Java, we are representing that real world entity employee as an object. So so that being said, you will be having a lot of employee objects, right? Employee one, employee two, and so on. A lot of employee objects you will have. So collections, when you say collection, employee collection, it means a group of employee objects. Okay, so when you say collection of employee objects, that means you're talking about a group of employee objects, like even into multiple objects you're talking about, right? That is called a collection. It's a group of objects, right? Just focus on this word, group of objects. A collections framework is a unified architecture for representing and manipulating collections, enabling collections to be manipulated independently of implementation details. So basically, when you have a collection like this, which is basically a group of objects, so your collection framework will help you to manipulate these objects, right? When you say manipulate it can be anything: adding more objects, or removing certain objects, or trying to sort these objects in a certain order, or it can be any set of operations, any set of manipulation, whatever we want, right? So to manipulate these objects, we have the collections framework in Java. So like I said, the collections framework standardized the way in which these group of objects are handled by our programs. Right? And I think this kind of Java 1.2 2000 or something of the sort. Back then we used to have dictionary, vector, stack, and properties. These four dictionaries, vector, stack, and properties. These four classes as part of interfaces, as part of collections interface, and later eventually evolved. It has evolved quite a lot, and today there are many predefined classes, which basically helps us to work with a group of objects, right? There are a lot of predefined interfaces. So these implementations, right? And the first key goal of this particular collection framework is to provide high performance. When you say high performance, like say for example, we are trying to access certain group of objects, right? We want to sort them, or you want to maintain those group of objects and then try to delete some objects and all, right? You need certain kind of a layer on top, which will basically help you to facilitate these manipulations quickly, right? At faster rate. So for that collections framework, it basically helps us to achieve that goal, right? We will see the list of standard classes and interfaces that collections framework comes up with, right? And there are a lot of the collections framework itself has a lot of algorithms which form the important part of the entire collection framework, right? There are a lot of algorithms, and they basically, these algorithms are basis for providing a standard way of manipulating these collections, probably the group of objects, right? And there are a lot of interfaces. Like we'll just see the hierarchy in a higher way, but you guys understood, right? Like why we have a collections framework: to efficiently manipulate the or work with the group of objects, simply put. Okay, so collections framework comes with a lot of predefined classes. If you see the table here, these are the predefined classes, but I'll just give this you in a hierarchy on how they actually exist. Okay, on the top of this entire framework, you have one interface. Okay, this is an interface. Okay, so I'll do one thing. I'll probably interfaces, I'll mark with okay, I think, yeah, this is an interface. I'll mark interfaces with rectangle. Okay, and the first interface is called collection interface. COLL is collection. So the first interface is collection. Okay. Now, if you see this, you'll find it. Probably open here, right? This is the interface of the first interface is collection, and it extends an iterable interface. We will just look at this at a later point, but we'll start from the collections interface. Okay. And from collections interface, there are three interfaces in addition, which basically extends our collection interface. Okay, 1, 2, and 3. Okay, three interfaces you have, which basically extends this collection interface. The first one is a set interface, and next one is a list interface, and the third one is a 𝑞𝑣𝑢 interface. Okay, and in addition to these interfaces, I'll just put the hierarchy here. So let me just quickly open the set interface. If you see, let's put set. If you go on here, you can see, right, interface set extends what? Collection interface. Okay, so the set interface basically extends the collection interface. Remember, guys, all these are interfaces only. None of them are concrete classes. And in addition to this, you have few more interfaces. Okay, one, you have a DQ interface. Also an interface. DQ. And then in addition to DQ, this extends this basically. DQ interface extends Q interface extends collection interface. Okay, and similarly for set also you have a few more interfaces. One is the sorted set. And you have another interface. Navigable. Okay. So if you see here, navigable set interface extends sorted set interface extends set interface extends collection interface. Okay, all these are interfaces, right? Interface in the sense they will just have empty methods without implementations, right? Before this, let's just try to understand what is a set, what is a list, and what is a queue, what is a sorted set, what is a navigable set, what is a DQ, and all. then we are going to talk about the concrete classes. Okay, so guys, whenever I say collection framework, you need to have this particular hierarchy printed in your mind. Okay, this is really important, the whatever the diagram, the hierarchy you're looking at, right? So throughout your experience when you are working with Java, you should have this hierarchy, this particular diagram imprinted within your mind. Okay, it's really important. Like even they'll ask you this hierarchy in a lot of questions also. Okay, so basically we'll just try to understand one by one. I'll just talk about all these interfaces. So this 𝑞, sorted set, navigable set, I'll talk about all these interfaces, why the what does this interfaces mean. Then I'm going to talk about the concrete classes which basically implement these interfaces, and we are end of the day we are going to make use of those concrete classes to work with the group of objects. Okay, so having said that, let's just talk about let's first talk about list. So is this clear so far? Any questions here? Any questions here? Any questions, guys?
No question.
Okay. I'll just share you this PNG for your reference. Okay. Yeah. Now we'll talk about. I'll just I'll open another. I'll open the new one. So now we'll first talk about the list interface. So basically, what is a list interface? As you already know, it basically extends the collection interface, and at the end of the day, your collection, whatever.
Your voice is breaking.
Okay.
It's not as clear.
Just give me a moment. I'm a bit coming closer to the mic.
Okay.
Is it better now?
Yeah, it's better.
Okay. So your list interface basically extends collection interface, and it kind of declares the behavior of a particular collection, which basically stores a sequence of elements. Okay. And these elements can be accessed by their position in the list using a zero-based index, and it may contain a duplicate elements. Okay, what you understood by this? This is something similar to array itself. Okay, so you know array, right? Array, it basically stores values in a contiguous memory locations like this, right? And here you will have indexes, right? Like for example, this is zero-based index, this is 1, this is 2, this is 3, and this is this is 4. Yeah, certain indexes like this, right? And it will contain some elements end of the day. It can contain objects. Let's assume we are talking about subjects, right? Let's assume here it contains E1, E2, E3, E4, E5. Okay. Have an employee, 5 employee objects stored in your array list like this. Okay. See, your array list is the same as an array. Okay, like the way it stores the data, the way elements are accessed using index, manipulated, like inserted or retrieved or deleted using index. Okay? It is kind of exactly same as array, isn't it? Yes or no? Don't you find the similarity between the array list and sorry, list and an array, right? But if you see here, and one another important point you need to consider is your list can store duplicate elements. When I say duplicate elements, here it can contain E2. Okay, so just here it can contain E2. That means E2 is present twice. Okay, the duplicates are allowed in array also. This is like nothing new with respect to the list. But what exactly is the difference is where your list can work, your array can work with primitive types also, right? Integer, char, those things also we can put it in array, right? But in case of list, we cannot work with primitive types. We can only work with object types. That's one key difference. You guys are following me, right? Have you guys understood like what I just said? I'm just talking about the differences between the list and array. You guys already worked with array. In array, we can store objects, we can store in array, we can store primitive types like int values, right? Whereas in list, it will only support objects. And array is a class, whereas list is an interface. That's another important difference. Okay. And so far clear? So when I say array is a list, list is an interface and array is a class, that means list is an interface. That means multiple classes can have different implementations for list. Yes or no? Right? That's one difference. Whereas your array list is a concrete class, so it basically has one implementation. Okay, so that is what it is. Okay, and let's just try to take some let's see what are the different implementations available for list. That will give you a more sense or more understanding between differences between these two. Okay, for yeah, for list, the concrete classes that are available was the first concrete class. I'm writing it here. Okay, so the first one is array list. Okay. And you have few more classes. Okay, one is linked list, and just let me just give, yeah, one is a linked list. One linked list. I will finish this diagram first and then we'll come back to the discussion. Okay? And coming to set, you have two more classes in set also. Okay, one is the first one is hash set, and there is another class which is basically linked hash Okay. So I'll just write all the classes and then we'll discuss the differences. Okay. Um, for a set, you have two implementations. So that means ArrayList is a class which basically implements the list interface. Okay. I'll just quickly show you here again. Okay. Suppose if you write here ArrayList. Okay. Now if you go and see, ArrayList implements, sorry, it extends abstract list. Okay. So there is one more layer, but we will just put this this way directly. Okay. So, and if you see this abstract list, this basically implements the, this extend implements the list. Okay. Have an abstract list class, and this array list class basically extends the abstract list. Okay. You have a sequence of abstract, lot of abstract classes in between. Okay. Like these abstract classes first implement these interfaces, and then the concrete classes extend those abstract classes. Okay. So you have, and for sorted set also you have not sorted set, I think you have it for tree set. Tree set is one. Okay, I think this is not right relationship. Okay, this is like this. Your linked list extends hash set. Okay, your hash set extends the set from set interface. Basically, your abstract set again. Okay, and then your linked list is basically extends the hash set, and then you have a navigable set. I think here you have a tree set, I believe. Let me just quickly check this. Okay. Tree set. Open, it extends abstract set, and it implements navigable set. And yeah. So here you have tree set. Basically implements navigable set. Okay. And coming to Q, I think we have two here. Okay. So I'll just look at the priority queue. I think this one extends priority queue. Priority queue extends abstract queue, and your abstract queue implements queue interface. Okay. So here you have priority queue. Okay. And for DQ, you have another class which is array DQ. Okay. So okay. So if you see, the one within the circles are the actual classes which we are going to make use of it. Okay. They are not, and the one in the rectangles are the interfaces. If you look at the hierarchy, right? List and set and queue, they all three extend collection, and DQ extends queue, sorted set, extend set, and navigable set, extend, sorted set. So you have a tree set, which basically is the implementation of the navigable set, sorted set, and set. All these three combined together implementation is tree set. Whereas your hash set and linked set, they are implementations of set. And you have array list and linked list, which are implementations of list alone. And I mean, linked list is kind of extended with abstract something else. There is one more hierarchy, I think, abstract sequential list. Let me just refer to this. Linked list, yes. Your linked list implements list and extends abstract sequential list. Okay, this extends abstract list. Okay, yeah. Like you have some abstract class in between. Okay, I want you guys to explore and work and understand what those abstract classes are to give you a better picture. Okay, but this is a overall collections hierarchy. In addition to this, there is one more also, not just this. In addition to this, we have another parallel interface. Okay, which is a map interface. I'll just write it and then we'll discuss it in detail. Okay. The next thing we have is, just give me a moment. Map interface. Okay. In addition to this, we have a map interface. And this doesn't extend collection interface, remember this. Okay, and you have a sorted map, which basically extends the map interface. Sorted map. And then you have navigable map. Navigable map. Okay. So these are the hierarchies. Map. Okay. And if you come here, coming to the concurrent classes, right? You have same set of concurrent classes again. Okay. For map, you have hash map. I'll just write the classes. For map, you have, there is another map also. Okay. For map, you have hash map. It is the concrete class. And for hash map, and then you have again linked hash map. Okay, which basically extends the hash map class. Okay, and then you have another map which is extends this navigable map. This is called map. Okay. So this is the overall collection hierarchy. I'm just sending you this updated image again. Okay, I'll just open this. Yeah, this is the for notations I will just put. What are the rectangles? Rectangles are What are rectangles? Rectangles are interfaces, and then the circles are concrete classes. Okay. This is our complete collection hierarchy. Okay. I'll just go to list now. Yeah. This is our complete collection hierarchy. Okay. You need to picture this diagram in your mind. Okay. When you are working with Java, because your skill basically lies in, you are working with a group of objects. You need to do certain thing, right? And your skill basically lies in which particular concrete class I would pick, right? That's what, as a Java programmer, you will be you should be able to make that decision. You have certain manipulation that you have to do with a group of objects, and you should decide like whether I would go for a set, or whether I would go for a list implementation, or should I go for a map or queue implementation. That's your first step, right? And then you would be looking at, okay, now I decided I'll move on to, suppose that you decided you will work with list, right? So what concrete class I'll pick? Should I pick array list, or should I pick linked list? So you basically need to make these decisions whenever you use any of these concrete classes from this particular framework. Okay, and it typically you can make that decision only when you know these the differences between each of them very clearly, in what functionality or in what scenario they are used and all, right? So I'll just finish the list, these both, and then we will talk about the rest. Okay. So as I was telling, list will basically contain an array based values like this, and it will contain values like 0, 1, 2, 3. It uses an index. The key difference between list and array is, if you see, list has two implementations, right? List is an interface, whereas array is a class. Your list has two implementations, which we saw. One implementation is array list implementation, and another is linked list implementation. So what exactly is the difference between this array list and linked list implementation? Suppose let's take an we are talking about list alone. Okay, now let's take an array list, and suppose in array list you are storing elements in this way. Okay. You stored in array list, you are storing elements in this way: E1, E2, E3, E4, E2. And when you print the array list, okay, when you print it, what will be the output? It will be same. Okay. E1, E2, E3, E4, E2. Okay, it will be the same, right? And when you print it again, for example, okay, just give me a moment. And here, one thing which you basically, just give me a moment, yes. Yeah, and another thing, right? Here, there is no, your array list doesn't preserve the insertion order, whereas your linked list, which is the other implementation of list, this basically preserves the insertion order. So what you understood by preserving insertion order? Preserving insertion order is something that the order in which you are inserting the elements into your list, right? It will be basically stored. I mean, it will be basically retained by your collection. Like, say, suppose you are inserting elements in this particular order, right? Like, for example, you first inserted E1, E2, E3. In this particular order, if you insert, this order is actually retained by array list. The next time you print array list, you will not see even E2, E3, E4, and E2 like this. It may print in some random order also. Okay, so this order is not always same when you print an array list. But whereas in linked list, when you print, it will basically retain the order in which you are inserting the element. So how many times you print linked list, you will get the. Is my audio still not clear?
It wasn't clear when you were explaining about the linked list in the beginning, but now it's clear.
Okay, so basically the key difference between for list interface, we saw two implementations. One is array list and another one is what? A linked list, right? Linked list implementation. So in what scenarios you will use array list and linked list is what I'm now talking about. See, and one, I think the another important differentiation I missed telling between list and array is when you are writing with array, you should also tell how many elements you are storing in array, right? Like 10, 20, 30, yes or no? You should know the size of your array upfront, yes or no? Do you guys remember this from our initial discussions?
Yes.
But whereas when you're working with list, it's a dynamic array. You no need to decide the size upfront. And in the runtime, you can add any number of elements. It will be dynamic. You can add hundreds, thousands of elements into that list. Okay, but whereas array, initially you should know upfront. If you tell your program initially, okay, I want 100 size array, later you can't change it to 200 or 300. It's not at all possible. Whereas your list, it can accommodate. You no need to mention any size when you work with list. Okay, it can just accommodate any number of size at runtime. So another important difference between list and array is your list is basically of a dynamic array. You can call list as a dynamic array. Okay, so normally in interviews they'll ask the difference between list and array. The one key thing you tell them is list is a dynamic array and list is an interface and array is class, and list will have multiple implementations, which is array list and linked list. Okay, and now we are talking about difference between array list and linked list, and in case of array list, it doesn't maintain any insertion order of the elements. The order in which you basically stored the elements or inserted the elements into that particular list, array list will not maintain that, whereas your linked list will actually maintain the insertion order. Suppose if you inserted objects 1, 2, 3 and then 5, how many times you look at the order of that linked list, it will be in the same order. But whereas in array list, every time it will give you a jumbled order. Okay, there is no predefined order for it, and your array list will always store objects, right? And let's just take a small example, and then we will understand this better. Okay, so I'm just closing all this. I am taking this. So here I have my employee class, right? So I am just generating setters and getters, nothing much. Okay. Generate source, generate setters and getters, select all. Okay. I have employee class, I have generated the setters and getters. Okay. Now if you see here in this class, I am creating 4 employee objects, right? First one name is Varsha, and then Varsha. I'll just use you guys' names, Shweta and Sheila. Okay. So you have different employee IDs, and I'm just assigning some values. Okay. For this, my E1 employee object, I'm assigning the name as Varsha, employee ID 123, employee salary 200K USD, something like this, right? And I have now how many objects I have for employee? I have 4 objects. 1, 2, 3, 4. Okay. So I have 4 objects, E1, E2, E3, E4, 4 different employees, right? Now look how am I making use of a list? Okay. Here I'm creating an temp list, which is basically nothing but employee list. I'm creating one list. Okay. Just cut this and paste it from the prompt. So here I'm creating that employee list, and look at the class. The interface is list, but the implementation I'm using is array list. And I need to tell the objects that I want to store in this list. I'm telling in this list I want to store employee objects. Then this list has this particular methods called add, E1, E2, E3, E4. So using this emplist.add method, when I call this add method on this list and I pass the object E1, I'm actually storing this E1 into this E1 object, this E1 object into this employee list I'm storing here. Okay. You see here, E1, E2, E3, E4, and it can also store duplicates, right? So I can add the same object twice here. Okay. And if you see the, and how I think till now it is clear, right? Up until this point. It's just that I created 4 employee objects and I inserted those 4 employee objects into my employee list, which is nothing but an array list. I inserted my 4 employees into an array list. Okay. If you see, the reference is of type list, but the class is of array list. Okay. So we, instead of list, we can also use this as array list also. This is also fine, but this is the best approach. Why do you think so? I think this you already know, right? Array list, emplist equal to new array list. This is how we create objects also, but here I'm putting list. I'm basically making use of runtime polymorphism, right? So what is the advantage of this? Why my EMP list of reference should be list rather than array list like this? Got my question, right? Why should I keep this as list rather than array list like this? Come on guys, what is the answer? What do you think? This will basically test your understanding of inheritance and everything so far. What is it, guys? Just think something, give some, say something. Why this is a best practice and this is not? Anyone? Whatever that strikes for you, right? Just that's okay. Whatever may be the reason, just say what you are thinking. At least I know whether you're thinking in a right direction or not, right?
So it makes the use of the abstraction and polymorphism.
Right. It is clearly making use of runtime polymorphism, right? But how it is taking the advantage of runtime polymorphism? Okay, what are the concrete classes for list we saw? There are 2 concrete classes for list, right? What are those?
Array list and linked list.
Right, that's good. That's right. Array list and linked list are 2 concrete classes for list, right? When you declare like this, tomorrow you felt for your implementation array list is not correct. So you can simply change this to a linked list like this. Okay, you can just simply change this to linked list like this. Lion. I don't know, n is not getting typed. You change like this, that's it, job done. Okay. And when you put it like this, you can never ever change this to linked list because it's of the simplicity is of type array list. Okay. Array list is a concrete class. It's not your array list is not a super class of linked list, right? Whereas if you see list is like a super. In the hierarchy, if you see list is the parent of linked list. So that's why you can do this. Is array list a parent of linked list? No, right? If you see the hierarchy, both array list and linked list are childs of list. It's not like linked list is child of array list. If that is the case, then you can put it like this. This is not the case. So this is not possible. So this is not a best practice. Okay. If at all you use list like this, then this is linked list right now, right? You can change after some time if you feel like no, linked list is not helping me. I want to change it to array list. You can change it. No one is going to stop you. So it gives you that kind of flexibility. So you are making use of the run. This is how you are making use of a runtime polymorphism here. Understood, right? In interviews, some interviews they'll ask you this also. Okay. And yeah, now like I was saying, right, in amplist we added these 4 employee objects. Now how can we print the employee list? We can print the employee list using the iterator like this. Okay, using iterator class. So when you call on amplist, when you call dot iterator method, it will give you this iterator object. And when you iterate this iterator object like has next, if you see here, right, it will just print the objects here. I'll just comment the rest of the code for you now. Okay, so I'll just print this. What will be the output when I print these E1, E2, E3, and E4? What will be the output, guys? If you see, I added E1, E2, E3, E4, and I added E1 again. What will be the output?
It will be all the names. And then again, the first name at the bottom.
Names are not printed. What is the output here? Using iterator, I looped through. Iterator will help you to iterate through this particular list. Iterate in the sense navigate one by one through this particular list. Iterator class will help me to iterate. So I iterated through this list one by one, and I'm just printing the object. When I say itr.next, it will print the object. Now, if you see, it actually printed the memory address of that object. Yes or no? It didn't print the actual values. Did it printed values, or is it printing memory addresses?
Yeah, just the memory address.
Why? If it is an integer type, then yes, it would have printed the actual values. But here these are objects, right? Object contains so many fields, right? Object contains 5 fields. How can this be converted as a string representation? How can we convert this particular multiple fields into a string representation? Any ideas? We have toString method, remember? toString method. You guys remember the toString method? Which is present in? Which is present where? Object class. Yes or no? object A, for example. Let's take object class C here, A dot. You have toString method, right? So I'll just simply override the toString method in my employee class. And here I will tell return employee name, employee ID, the salary as a string together, toString. So when I override toString method in my employee object class, now if I try to print this, let's see. Now I'm basically creating a string representation. Now if you see here, I created a string representation, employee name, employee ID, and salary, separating them with hyphens like this. Okay. And when you see this is the output. Okay. Here for other employees, I didn't define the employee ID and salary. That's why it is saying null, null, null. Okay. And how many objects I have? 5. Employee 1, 2, 3, 4. Employee 1, I duplicated it. So that's why you see it's printing 2 times here. Okay. So basically to print an object in a string, you need to override this toString method and provide it string representation. If I just put it the name here rather than like this, right? Just comment this part, and if I just return the employee name, then it will just print employee names itself. If I just remove this, I just return the employee name, right? Now if I execute this, it will just have a string representations. Okay. Understood, right? Any queries here?
Could you send this code to a message chat message?
Yes. I'm just sending you, but we'll stop here, guys. I think we need another 15 minutes of discussion on collections. Okay. I'm just sending this PNG image again. So tomorrow also we'll try to discuss some for 30 minutes. I think we will close the collections part, and later I'll take any questions you have on Java. And I think then the day after class we will start Spring Framework. Okay. So we'll just spend tomorrow also on Java again. Okay. So I shared the PNG image again. I want you guys to memorize this. I want you guys to memorize this particular hierarchy. Okay. I hope you are following this today's class, right? Or does it sound too much complicating? What is it? Are you guys able to follow it?
Yes, I mean the diagram is pretty much understandable, but we don't know like what kind of scenario we are using it. All of the those linked.
I gave you guys one Java assignment, right? Remember, in this you have these, initially you have string programs, right? And then all these programs, they make heavily use of the collections. So if you implement these programs correctly, then you will be good at this collections framework. Okay, this 4, 5, 6, 7, 8, 9 programs you are seeing here, right?
Yes.
This will help you to get a good understanding of collections. Okay. See, just that you can, one thing you need to remember, you think about the difference between array and collection. Your collections are a dynamic size. You no need to predefine size at the initial, at runtime. You can extend your collection to any number of elements. You can add 1,000, 10,000, any number of elements. You not need to know the size of your collection upfront. That's one advantage. And that insertion, deletion, manipulations are pretty much faster in collections. Because in array list, we used to add, how we used to add elements in array list, we used to say a of 0 equal to 1, a of 0 equal to e2. This is how a of 1 equal to E2, a of 2 equal to E3. This is how we used to do, right? But in case of list, it comes with the add method. It comes with so many methods like this. You guys are understanding, right? When I'm explaining, if you try to correlate it with arrays and C, then you will clearly understand these collections pretty much. Okay. The both arrays and collections you have for a same purpose, working with a group of things, group of integers, group of objects, and all, right? Okay, we'll stop here, guys. Tomorrow we'll do one more class on